Sketching quadratics example 2. We have y equals 3x squared minus 4x minus 1. And the first thing I'm going to note is the coefficient of x squared is 3, which is positive, and therefore I know I'm going to get a happy curve. I didn't mention that in example 1, but indeed the same situation was there. The coefficient of x squared in example 1 was 1. From here, I can tell that the y-intercept is 0, negative 1. Now if you try to factorize this, you'll find that you can't, and so finding the x-intercepts might be something that we're not expected to do in this particular example. But I will go ahead and do that anyway, but I'm going to complete the square first to find the vertex. So what I need to do here is take out 3 from the first two terms. So that would give me x squared minus 4 over 3x. And then don't forget the minus 1. If you re-expand that, you'll see that you do get the first two terms. And then we complete the square inside the bracket. So that's going to be x, take away half of negative 4/3. So that's going to be negative 2/3. Squared. Now if you think about expanding that out, it would give you x squared, it will give you minus 4/3 x, it will also give you a plus 4/9, that's 2/3 times 2/3 that we don't want. So let's take that away, like so. You might need to walk yourself through some of this. Re-expand, and we get 3x minus 2/3 squared, and then 3 multiplied by negative 4/9 would give me negative 4/3, and don't forget the minus 1. And of course minus 1 is minus 3/3, so we have 3x minus 2/3 all squared, take away 7/3, which tells me that the turning point is at 2/3, negative 7/3. Now suppose we did want x-intercepts here. We could use the quadratic formula or use this completed square form. Remember, we'd want to solve 3x squared minus 4x minus 1 is 0 for the x-intercepts. So we've got 3x minus 2/3 squared, take away 7/3 is equal to 0. So 3x minus 2/3 squared would be equal to 7/3. So x minus 2/3 squared would be equal to 7/9. Just divide both sides by 3. We can now square root. So x minus 2/3, don't actually need the bracket here, would be plus or minus the square root of 7/3. We're square rooting all of this, but the square root of 7 is just root 7, and the square root of 9 is 3. And so x would be equal to 2/3 plus or minus root 7/3. And that might not be that enlightening to you, so it would probably be best to have that as a decimal. So I've just gone ahead and used my class pad to work these out as decimals. And so we get negative 0.22 and 1.55 correct to 2 decimal places. So that's easier to place on a graph. So we have everything we need now in order to make a sketch. So let's sketch. So we need some axes for our sketch. And then we've got x-intercepts, like so. The turning point needs to be between. And then we're going to try and sketch. We know that the y-intercept is at -1, so we must make sure that it crosses the y-axis below here. It's hard to do that going from there to there without crossing below the x-axis anyway. Try to make it look reasonably symmetrical and quadratic shaped. And then we've got the turning point here, and we know that that's at 2/3, -7/3, and we'll just put this one as 1.55 and -0.22. Of course, we could put the exact values here on, and we know that the y-intercept here is at -1, and then we should label. So this is y is equal to 3x squared minus 4x minus 1. And just look at the x-intercepts for a moment. 2/3 plus √7/3 and 2/3 minus √7/3. We know that this graph is symmetric about a vertical line through the turning point. That would be the line x equals 2/3. You don't necessarily need to add that to the sketch unless you're asked for it. But we can see that from the exact nature of the roots. We've got 2/3 add an amount and 2/3 take away an amount. So it's clear that 2/3 is in the middle, and then one of the roots is up √7/3 from that, and the other root is down √7/3 from that. So it's clear that 2/3 is symmetrical, or the curve is symmetrical about x equals 2/3.